So, how do parapet conditions affect a building's compliance with local law number 11, also known as FISP or FISP, and what should structural engineers keep in mind when working on these projects?
One of the most things that I see in parapets are, as I mentioned, the cracking, which is very obvious and people can document that. But many times parapets fail in a start to fail in a very discrete manner of bowing and bending. And you need an experienced eye to look at parapet.
Did you know that something as small as a loose parapet can put an entire building out of compliance with local facade inspection requirements and pose serious safety risks to the public? Whether you're managing a high-rise in a major city or a historic building in a small town, regular facade and parapet inspections are critical to protecting not just the structure itself, but the people around it. In this episode, we are joined by Domingo Diaz, president of Diaz Architect Associates PC, who has spent over the 38 years helping building owners navigate the complexities of facade restoration and compliance. Dom will share what you need to know about keeping your building safe, the most common issues that lead to violations, and why proactive maintenance is the smartest investment you can make. If you're responsible for a building or just curious about what keeps them standing safely, this episode is for you. I am your co-host, Alex Dado.
And I'm your co-host, Matt Picardal, and this is the Structural Engineering Channel. All right. Dom, thanks so much for joining us.
Thank you for having us.
And can you tell us a little bit about yourself? What sparked your interest in facade restoration and inspections, and how did that lead you to starting Diaz Architects and Associates in New York City?
Yeah, well, I've always been interested in the anatomy of a building, all the different types of construction technology that started from the late 1800s to present times, and the evolution of the assemblies, the introduction of steel framing, how that interacts with the building facade, the evolution of metals and its non-corrosive properties, and flashing has a lot to do with the success of many, many buildings. My interest in that and some projects that I worked early on really introduced me to a field that I thought needed to be addressed, and then I thought I saw a need for an architect in building forensic, facade restoration, building envelope restoration, better yet said. So that's how I ended up starting Diaz Architects, because I saw a need for that.
And it seems like you bring a unique perspective in terms of with architectural. I know there's some structural work, but I think that unique perspective of being an architect can be beneficial, and you can watch out for things that maybe engineers don't know too much about, or that may get easily overlooked.
Absolutely, yeah. There's a lot of elements of how the architectural elements interact with the structural elements and how they affect each other. There are various different issues that need to be dealt with, from expansion and contraction, flashing, as I mentioned, and how that all interacts together and keeps a building intact, but at the same time properly functioning, but intact with the structure. So.
Sounds very interesting. And it sounds like there's a lot of different things to consider when you're looking at a facade. Durability on the engineering side starts to be a question almost immediately. So why are facade restoration and regular inspections like parapet inspections so critical for buildings, and what makes these inspections necessary in the first place?
Well, buildings, contrary to most building owners, buildings are constantly deteriorating. Just because you have a repair campaign doesn't mean that you've addressed all the issues, and it doesn't mean that certain materials that have not been addressed will not continue to fail and deteriorate. So a 5-year cycle seems to be a very appropriate time to catch materials that do deteriorate and address them in some remedial campaign. Now, parapets are very, very special architectural component because, as we all know, they extend above the roof and they're absorbed. They absorb water from the outboard face, the inboard face, the top side. So they're exposed to elements tenfold than other elements of a building. And then you add the fact that maybe a roof is failing or deteriorating, or a lintel immediately below a parapet is starting to exhibit rust jacking and starting to twist and turn, affecting the parapet. You have a component of the building that's very vulnerable to movement, displacement, cracking, and obviously it's also subject to a lot of lack of redundancy that other building materials, building areas don't have. So you may a failing parapet that's not addressed immediately could have some detrimental effects to the public.
Are those effects essentially? I'm assuming in New York City, because we're obviously here in the West Coast. I am curious about New York City in terms of there's probably a lot of rain, snow, and wind as well, where that all. Or I'm guessing that's the beating that you're talking about, right, with the parapets?
Well, that's one aspect of it, but in colder climates like New York City, we have repetitive freeze and thaw cycling where water enters a parapet, it freezes, it expands. Once it expands, it creates cracking. And if you repeat that cycle numerous times, you're going to have more cracking and more areas that are displaced because of that. So the Northeast does provide some unique weather conditions that other areas of the United States don't have.
And that, I'm guessing, that leads to sometimes structural failures. What type of failures do you typically see in terms of that you're trying to prevent?
Well, typically we will see a water introduction into a spandrel beam immediately below a parapet. And what happens is you have some structural deterioration with the expansive forces of steel. Corroding steel will push up a parapet or bend or bow a parapet out of place. And then back in the days of pre-war buildings, many of these parapets were never tied to the structure. They were always independent elements. So there's very little redundancy in their design.
So, how do parapet conditions affect a building's compliance with local law number 11, also known as FISP or FISP, and what should structural engineers keep in mind when working on these projects?
Well, one of the most things that I see in parapets are, as I mentioned, the cracking, which is very obvious, and people can document that. But many times parapets fail in a very start to fail in a very discrete manner of bowing and bending, and you need an experienced eye to look at parapets from the outboard face and the inboard face. Many times I've seen parapets have convex profile from the exterior and look very good on the interior. So from a structural point of view, we need to look very carefully at these elements and notice how they're interacting and behaving. Also, parapets in a typical bonded wall construction, you'll have header bricks that tie the walls together, and that creates the cohesive nature of the parapet. But there are many parapets that don't have those header bricks, and are more vulnerable to quick deterioration or separation, and can fail much quicker than your typical bonded wall. So, although that is an architectural component, sometimes structural engineers need to understand how the wall is constructed together.
Yeah, I think that's something that with the detailing that goes into it, as structural engineering, when I look at parapets, at least on the West Coast, we're looking at the studs or the steel or the concrete, and yeah, we're mainly concerned about what the structural strength of it. But then you look at an architectural detail of a parapet. Sometimes those can get pretty complicated in terms of the layers, the materials that's being used, like you said, the flashing as well. And I think those are if engineers that aren't used to that. All those things have a purpose. So it's
Exactly. Including, if I may, including through wall flashings create natural shear planes in the parapet, where the mortar cannot stick to the metal, and therefore these shear planes are very the parapets can fail very easily at shear planes, and then you introduce other deterioration, as we just mentioned, you can have a parapet that fails very quickly.
yeah, it's always interesting to see where when there's specialists, there's a reason for it, where all these things that come together can become a complex assembly where yeah, it makes sense to have specialists for those.
And the battle between structures and architecture just continues and continues.
Or combining both of them too, or so like, yeah, it seems like they all interface with each other, the architectural components, structural, and then you're gonna have to know both of them.
I like to think we're husband and wife, in certain instance, we need
Yeah.
to work together to make the marriage
Yeah,
work.
it's a team. Could you tell us about the upcoming subcycle 10A deadline in 2025, and what should building owners know about that?
Well, I mean, one of the most common things that owners have this false realization is that buildings that go through a repair campaign are automatically fixed, and nothing will have to happen to these buildings. As I mentioned previously, um, every local law 11 cycle will expose other components of the building that were not touched to a repair. And owners have to adjust their realization, especially pre-World War buildings, because they're constantly failing because of conditions. Now, for example, I have buildings where we have brick bonded to a speed block clay or terracotta backup wall, and in many cases, that assembly is not an ideal assembly because of the hollowness and the brittleness of the backup terracotta wall. And it's basically adhering to each other through the mortar, and it's subject to a lot of movement from time to time, and cracking usually develops in the backup wall before it develops in the brick wall, and then you see sometimes that cracking being developed in the face brick wall. So owners need to adjust their expectations. A building with no flashing on the lintels, okay, at one repair tech campaign, we took care of 50% of the lintels. You have to understand that the other 50% will at one point also need to be replaced. And it's very cost prohibitive to any owner to replace all the bricks, all the flashing in one point. It's just not realistic.
Mhm.
So that's one thing that owners need to understand about it. And they annual maintenance plans are also very important. And building owners shouldn't wait till their 5-year cycle to start doing stuff on their facade, simple stuff to their facade, caulking of copings, um, you know, things that can be done with easy access is really, really important.
Yeah, that actually brings up something I wanted to ask a little bit more about when you're budgeting for maintenance, and you said a little bit about caulking, but what is the most proactive way to plan for upkeeping to try to kind of reduce those emergency repair costs?
Owners should always think of a building and their repair campaign in a very comprehensive manner, in the sense that they need to understand that a failing roof or probably will affect a parapet. A failing caulking in a coping may affect a parapet. There are many conditions that affect other components of a building, and when one is planning on a comprehensive restoration campaign, they should really expand their repair campaign to include roofing and waterproofing issues that will minimize the future repairs that will be required.
That makes sense. You try to find everything when you open it up and get everything addressed so you don't leave kind of one weak point to continue deteriorating as you go.
Correct. We always want to avoid emergency repairs. Emergency repairs are usually more costly. They usually involve a structural component. They usually involve much more an expansive type of work. If a roofing is failing, obviously it'll affect the parapet. It may now affect a small area of the parapet, and it'll affect a larger area of the parapet. It'll affect the lintels. It affects a lot of things. So a simple, you know, $20,000 repair now becomes a $200,000 repair, and very disruptive to the
Mm.
operation of a building.
I just had a follow-up question on that one. For when the parapets get damaged, is it mainly, or maybe it's a mix of both, is like the worry that, oh, if there's like a crack or water leakage, it's going to seep through? Or is it more of a structural where, oh, the parapet's going to fall or a piece of the parapet's going to fall and hit someone down in the street?
Well, yes to all the questions, and if you see a crack on the inboard face, the first thing we always look at is we see if the crack has gone to the outboard face of the parapet, and vice versa too, because a through wall crack obviously leaves a section of the parapet unstable. So a little hairline crack will turn into a medium-sized crack and a wide crack, and something as thin as a 16th of an inch will cause havoc in a building, introducing water into steel components, and then therefore the corrosive expansion of the steel starts to uplift the parapet, and obviously it starts to push out the roof flashing, and then the roof flashing starts to deteriorate, and it's a
Yeah.
compounding problem that has to be addressed immediately.
Mm.
So yes to all the
How
yes.
does your approach to modern buildings versus more of a historic building? How does your approach change for dealing with one and the other?
Well, interesting enough, when we're looking at a historical building, we're always trying to see if we can repair something, if possible, in place. Repair is more preferable than replacement. But in many cases, because a repair has a shorter lifespan, in certain aspects of a building, we may be forced to utilize the replacement option. Replacement of certain components of a building can involve replicating the exact material or maybe even considering some substitute materials that most people cannot tell the difference. It all depends on costs, it depends on fabrication, length of time. So those are two issues that we're constantly dealing with when we're approaching a historical building. So also sometimes we may have to anchor something back. We've used some of your Simpson products also to anchor some material back in a safe manner as well. So I think those are the major things, but understanding that owners need to understand that a repair may have a short lifespan. And when we say short lifespan, we may mean like 10 years, where a replacement option may have over 50-year lifespan.
Yeah. Sometimes it's a little hard to come in there, make a quick repair, and promise that whole 50 years over and over.
Yeah, yeah. One other aspect too is, once you open something up, you really need to address the structural ordinance of present time. Back in the days when things were built, sometimes they took a lot of liberties and the code was not as strong as it is today. And therefore, you're caught in a situation where do you rebuild something to today's code standards? And in doing so, you have to maybe perhaps introduce more structure. You may also need to expand the restoration of that wall or parapet to accommodate that. Obviously, you can't repairing or introducing some structural modification to a wall that's not failing is not something that we would do. We only fix what's broken. So.
Gotcha. Yeah. And I imagine if it's older, it could be historic, could not be historic, but really anything having to do with the building envelope is aesthetic and visible. I've always worked on the structural side, so as I'm always trying to figure out how to get things to stand up and stay where they're supposed to be, but that visual aspect ends up being more important to the owners. So, in your experience, how can structural engineers and architects collaborate more effectively during facade and parapet restoration projects so those owners get what they want, or the historic review board gets to maintain the building? What's the best process for us to collaborate?
Well, one of the issues that as architects, when we approach a project, most times owners want a number from a contractor that's a finite number. Everybody hates change orders. And many of the structural engineers that we deal with, I have to constantly remind them that you're never going to be able to see all of the conditions because probes are limited, drawings are limited, and sometimes you need to take an educated guess on the repair of something. We do that many times, and it doesn't mean you have to replace a column or replace a beam, but you need to understand that you have to assume that there's some repair required there, and you have to address that in your construction documents so you can buy a number from the contractor that is some number that you could always get credits afterwards, but there is and in construction administration you'll confirm the exact field condition. So that's something that we're constantly working with structural engineers to kind of because in their world, I think they just want to see a condition and come up with a design. And we kind of have to educate them. You have to forecast sometimes what the condition will be. It becomes a big training method that you have, because at the end, the owner's not going to. Seldom do owners want to deal with a condition that's a change order. and we want to minimize that.
Yeah, it's not the smartest thing to just assume when they open up that parapet, it's all structurally good. The minimal work
Right,
versus
exactly.
yeah,
Right,
based on maybe
exactly.
some of the building conditions, the age of it, you could do a good guesstimate of, oh, it's probably going to need this type of work. I bet it's probably not up to code, so they may need to reinforce it this way. Versus if you try to catch that after they started working on the project, that's when the owners get iffy about the change orders.
Right. I mean, if you see major walls displacing from the remaining portion, you could assume there is some expansive forces of steel exerting pressure on that wall. And you can assume that there's going to be some channel reinforcement, steel plate reinforcement um, on that structural steel member, and you can buy it in the job. And if it changes, you could always educate the owner that this is an unforeseen condition. We took the steps to coming up with a reasonable design, and we have something in there. It's a small change order. It may be a credit change order. So
Yeah, for those completely unforeseen, maybe not completely, but very unlikely. You see something that's like, oh, no one expected
right.
that, or that's really bad that we're expecting that. And then yeah. What are some of the trends that you see coming in New York City's building regulations that engineers, architects should be preparing for?
Yeah. Well, on the last cycle that we just completed, cycle 9, the Local 11 ordinance required us to confirm the condition of the ties,
Mm.
brick ties, in a cavity wall construction, and the frequency of their location as well. So they did require us to do probes at every drop where a cavity wall existed, and that in many cases we performed that, and in certain cases we found anomalies of cracking, maybe, who knows, 3-4 feet high in certain locations of the building. And we did probes in those locations, and we peeked behind the brick in the cavity wall, and we saw no ties. So we made an assumption that the walls had no ties. However, we then supplemented our observations by using ground penetrating radar, and sure enough, we saw patterns of where ties were omitted from the wall. And we were able to locate and save the owner a lot of money in the restoration, that these areas were in good condition because we saw the presence of ties, and these areas that maybe were showing cracking and sometimes not showing cracking lacked the ties, the frequency of the ties, and were candidates for pinning and reconstruction where the cracking existed. So that was something that I think that combination of non-destructive testing and destructive testing help each other out. The DOB is a reasonable entity, and once you present this information, they're all about utilizing your experience and perhaps even allowing this to happen as well in their ordinance. Another thing that I think things that need to be addressed in the future is any projecting element from the building, especially older buildings that project beyond the plane of the facade. Cornices are elements. Usually, they're clad with terracotta. They usually have a waterproofing issue on top of it with little drains. All these elements, and they have embedded outriggers, steel angle outriggers, where these terracotta elements are hung from. You know, this is like a sleeping tiger, I think, where there's going to be conditions where these cornices will have to be addressed, especially from a waterproofing standpoint. In many cases, we all address them, but I think they probably will require a lot more, maybe, scrutiny, similar to the brick ties. Any element that extends beyond, because there's very, very little redundancy. Once these elements crack, if they could easily fall to the street because they project out from the building. They can't lay within a wall cracked for a long time.
Yeah, something falls off.
Yeah.
That's literally a rock falling from a high height.
Yes. Yeah.
Dom, have you ever opened up a facade and seen that there were brick ties, but they are all since corroded and gone? Does that happen every once in a while?
Yes. Early generations of cavity wall constructions did use non-galvanized ties, and in cavity walls, I've seen them in parapets where you would have two whites on the interior, one white, and then the coping joints would allow water to come in, and you would see the corrosion to the point where they've eroded to nothing. We've seen ties, and you could see them sometimes in the joint because they blow out the mortar joint very easily. And once you start scraping that mortar joint out, you'll see the dust of the rust corrosion, because they're such a thin element that they erode very easily. So yes, corroded ties are a very, very serious thing, and luckily they haven't. It was used very early in the cavity wall development, evolving probably in the early to mid '60s. And then I think people realized that galvanized and stainless steel were the way to go.
I'm always curious how they held up even with galvanizing, because like you said, it's a very small, thin piece of metal, and it's often tacked back to wood or cast into something else that's cementitious that can see moisture. I've done plenty of old building inspections where that's like the first thing that we're noting. So I guess that kind of leads me to another question, which I'm just tacking on in general. But what other types of deterioration that you see, not specifically on the architectural side, but on the structural side, since we are speaking mostly to engineers?
Well, one of the things I do see is the relieving angles in a cavity wall. I see those failing in many cases. Sometimes the bolted connection from the relieving angle to the backup wall, in many cases, are not done correctly. And early generations of fabric flashing, like the nervous straw flashing, has deteriorated in time because the plastic brittle plasticizer in that flashing would evaporate and make the plastic flashing brittle, and therefore it would crack during times and expose the angle in the bolt to a lot of corrosion, and then the angle would unfortunately start to rotate. And once it starts rotating, it starts pushing the wall out, which is a very serious danger. And because you only have a one white wall, and you can have an instantaneous issue there. There are some examples in the history of Local Law 11 ordinances that has happened, failures of walls. And also people sometimes cut a hole or a window into an unreinforced brick cavity wall, and that condition also leads to failure in the brick wall as well.
Yeah, those unplanned openings always give us an interesting problem to solve on my end.
Where's the permit for
Yes.
this?
Yeah, that too. Where's the permit?
Yeah, definitely. Unpermitted, unsupervised, just out there with the Sawzall doing your best. I did have another question that went back a couple questions ago, but you mentioned when you're inspecting, there's a spacing. Is that line up with the prescriptive facade anchorages, or is it a different spacing based off of this?
Well, the New York City code requires spacing of anchors 16 inches on center, horizontally and vertically. So, in most cases, prior to that ordinance, most manufacturers, most brick installers would utilize that parameters. However, we've seen it the spacing go 2 feet, which 2 feet by 2 feet, which I think depending on the situation, people would feel comfortable with that. But anything beyond 2 feet, people would feel very uncomfortable with that. And again, it depends on the condition. If it's a 20-story high wall on a relieving angle, I'd feel a lot less. I feel much more a requirement to install pinning to supplement something of that nature, something on a 1-2 story bulkhead. That's less of an issue.
That's just a little bit of consideration for exactly what you're looking at. And
So
I like the prescriptive anchorages are obviously very easy for everybody to understand up front. And I know in the code there's a might not apply in New York, but there is an option to actually calculate flexural capacities of your masonry veneers and space those further out. But I can remember when I learned about it, wondering why you would want to pick up that efficiency and not build in the extra redundancy. And maybe it's a question of how much the owner wants to spend, but I think probably you can support this as you go on in time. Redundancy is what saves you money.
Exactly. I totally agree with that. A little belt and suspenders is always well worth it.
Yeah. Give yourself an option in case something fails. Well, I appreciate you answering all my extra questions. But before we wrap up, what are the most common questions you get from property owners about facade inspections and restoration? And what final thoughts would you like to give to our listeners?
Well, I mean, sometimes when most projects start, most clients will look at their previous local law 11 report and ask, when do I need to repair this? And it's obviously very stated very clearly. We call it a cure date. The cure date is this date, and how can we extend this? And very seldom can you extend it. There are ways to extend it if the condition has not deteriorated significantly. However, you would really have to repeat the close-up inspection process for my liking to allow that to happen. And it's a per situation basis where one stone on this area may require to be replaced, and the other one can be with maybe some small pinning. You could add another year to it. But nevertheless, that is a common question when a project first starts: is do I have to repair it? Can I extend it? My final thoughts are, I always say to owners that you should always select a very experienced restoration architect when you're performing a restoration campaign on your building. It's not just doing a local law 11, but there's a whole process involved in terms of managing the project, scoping it correctly, creating allowances in order to accommodate times when you have these field conditions, and also establishing a process with the contractor with initial inspections, final inspections, and interim inspections in order to maintain quality in the project. Many times these contractors are well-meaning, but they don't understand the concept of brick ties every 16 inches on center, flashing conditions, how flashing shall extend out to the exterior, end dam flashings at lintels, and sometimes you're forced to be their instructors. uh, And although we don't want to be like that, you only experience restoration architects and engineers have that ability because of their past experience. So I would always advise owners to carefully interview your restoration candidate and select them appropriately. They'll save you a lot of money, and you can do quality work at the same time. They'll save you money in the future as well, which many people, a lot of people don't appreciate until it's down the road. But it makes a big difference.
Yeah, I had a architect friend who has his own business, really good, but then he was telling me stories of, the contractor would just want to go with the cheapest one, and he's like, no, I'm not changing my price because I do good work. And then the contractors would eventually come back and be like, please be our architect. And then he would raise the fees up because it's like, I told you. it's like that lesson that they have to learn like the hard way, where it's, for specific work, if you want good work, you got to find the right people.
Well, it's come to a time where many contractors expect the architect or the structural engineer to be their foreman. And we're not there to be your foreman. We're not there to tell you how to repair something. The drawings are there. You have a foreman to do that, and in these times where people are constantly selecting contractors based on low price. And I'm not saying that competitive pricing is not something that owners should look at, but the lowest price is sometimes not the best for the job from the contractor standpoint.
Thanks so much, Don. I appreciate you coming on and talking to us about this. It's always interesting for me, at least, to hear about these topics that I've dealt with but don't know all the intricacies of. And it was really cool to hear about all the intricacies that go into this type of specialized work. So I definitely appreciate it.
Thank you very much for giving us the opportunity to talk about it.
Absolutely. I hope you enjoyed the episode today. We'd love to hear your feedback, comments, and/or questions. To leave them, please visit structuralengineeringchannel.com. There you'll find a summary of the key points discussed in today's episode, as well as links to any of the resources or websites mentioned during this episode. Don't forget to subscribe to Apple Podcasts, Spotify, or wherever you listen to your podcast. Until next time, we wish you the best in all of your structural engineering endeavors.